Okay, so the way that I would approach number four is probably by drawing a sawhorse projection. And the way that I visualize this is I split the molecule down the middle here, and then I assign left and right either away from me or towards me. So I like to say that the left is going away from me and that the right is coming towards me. And then I can draw my sawhorse projection. I'll look at the front carbon first. We'll make it blue. And I've got a Cl that's in plane. I've got an a methyl group that's coming away. We'll leave that off. And we've got a hydrogen that's coming towards us. And then what we don't see is that carbon-carbon connection. And that is going to be in plane as well, since I've given the left and right forwards and backwards. The carbon in the back, the connection of carbon has to be in plane with the Cl. And then I can look at the back carbon, which I'll draw in red. We've got this, we've got this, and we've got this. And so we can see that there's a chlorine coming down, there's a methyl group coming forward, and there's a hydrogen going back. And now I have this molecule drawn as a sawhorse. So and again, we have that carbon-carbon connection here that's still in plane. And so you can use this to break up this compound. So we can draw a line down the middle here and say Cl in plane, methyl away, hydrogen's coming forward, and that carbon group is going in plane to the right. And we'll call it R for now. In the back carbon, we can say that there's that hydrogen that's going away from us. There's the methyl group is coming towards us. The chlorine is in plane. And that means that that R group, which we can see right here, is going to be in plane still, but it's going to be coming to the left. So we'll call that R. And I'll label these. This one is this, and this one here is this line here. We've literally just kind of taken the molecule and split it into two chiral centers. And then you can assign your priorities. So you can say chlorine is 1. We know hydrogen is 4. If there's a methyl and a hydrogen, methyl is always going to be 3. And then that R group means that that's 2. And since these atoms or groups are the same on both, we can go ahead and assign these as well pretty easily. And then we can do our rotation. So we've got 1, 2, 3, but we've got hydrogen in the front. So we've got to change our rotation. This looks like R, but it's actually S. So this one's S. Then we can do this one, 1, 2, 3. This one has hydrogen in the back, so we're good. So we can do 1, 2, 3. This looks like R. It is R. And that means that is R. So we have this plane of symmetry here. And we also have these two chiral centers that have opposite what do they call it, directions, absolute configurations, I think it's a technical term. But they're opposite of each other. One's S and one's R. So these cancel each other out. So that's what defines a meso compound. So just knowing that, you can say that this one looks meso. But let's look at the other ones just in case. And I'm just going to move these over a little bit. Oops. Well, never mind. It's not going to let me. Here we go. So we can look at this one. So let's do the same thing. Let's split it in half. So we have this line here. And we've got our front carbon, which we said was blue last time. So let's keep it blue. We've got this, this, and this. I'm going to say that this one is going away. This one's coming towards. On the back carbon, this one's going to be going away, and this one's going to be coming towards. The C and the H are going to be in plane. So let's draw that front carbon. We've got Cl in plane. We've got the methyl group going behind, the hydrogen coming out, and that R group, that bond to the other carbon in the back, is going to be going to the right. And that's because we're going to connect it to the back carbon, which has this H here coming up and in plane, or down and in plane rather. The methyl group is going away from us, towards us. Wow. And then the chlorine is going away from us. And so we still have that R group is going this way now. And so we can break that in half again and draw them as two different chiral centers. Cl, just the same as we did there. That R group coming towards the right on the front carbon, and Cl is now going away. Methyl's going towards. H is down here, and that R group is coming in plane to the left. And you could connect these really easily, which is the point, is that we're really just showing that they're two different things that can be connected to make this bigger sawhorse projection. And then go ahead and assign your chiral direction. So we've got one. These all have the same thing, so we don't really have to think here. We just number. The hydrogen is in the front here, so we have to be careful. We'll say 1, 2, 3 looks R, actually is S. So we can say this one's S. Let's look at this one. 1, 2, 4, and 3. 1, 2, 3, 3. But hydrogen is in plane. And we don't want hydrogen in plane because that makes it complicated. So we want to do some swapping. And I learned that swaps are the easiest way to do it, I think. So if we do an even number of swaps, or let's do this. If we do an odd number of swaps, we get the enantiomer. If we do an even number of swaps, we get the same compound. So we want to swap an even amount of times so we can get the same compound and we can figure out whether this is R or S. So I'm just going to change the numbers, but you could rewrite it however you want. Let's take the H, because it's our first priority, and let's put it in the back where the Cl is. So we've got 4 there, and now we've got 1 here. That's 1 swap. So we're going to keep track of our swaps. We've made 1 swap. Now let's swap again. I'll put 2 here and 3 here. Now we've done 2 swaps, so we should be back to the same compound. And now we can assign that rotation. Just 1, 2, 3. And this is looking like it's S. So now I have S and S. Well, I've got that same plane like I had over here, where I've got a line that I can draw and split the 2 chiral centers up. They've got the same groups attached, but now we have S and S, and those won't cancel out. So this is not meso. We can do the next one just the same way. I'll shrink this down here. For the next one, we have a front carbon and our back carbon. The front carbon, we're going to say this is going away from us, and this is going towards us, and this is in plane. The back one, we'll say this one's going away, this one's coming towards, and this one's in plane. And then we can just draw them. H, chlorine, and methyl. And then let's draw that carbon group. Let's connect the back carbon to it. So we've got Cl going down. So I'll put that group here, Cl. Coming down, we've got the methyl going away, and we've got the H going up. And I put that, oops, well, those are my text messages and everything else. Okay, so now we've got that carbon-carbon connection shown there in red and blue. That's just the connection of the front and the back carbons. And then we can break it in half, again, like we've done, and we can draw them separately. So we can say that we have that H coming down in plane, our methyl group, our chlorine, and then that group, that R group, and then over here we've got H going back, the methyl coming forward, the Cl in plane, and again that R group coming towards the other R group. Then just label your priorities again, 1, 3, 4, 2, 1, 3, 4, 2. Give your rotations. Where's your hydrogen? It's in the plane, so we need to fix that. So we'll do some swapping. So let's switch these two to give us 1 here, 4 here, and then let's switch these two, 2 and 3, and that way we've done 2 swaps and we have the same compound. Those are just hash marks. And then we can do our rotation. We've got 1, 2, 3. I didn't put the H in the back, so that wouldn't work anyway. Let me try that again. Let's put the H in the back where the 3 is. So this would be 4, and this would be 3. Let's switch the 2 and the 1. So this would be 2, and this would be 1. Now we have it the right way. So now we would have our H is in the back. Our group 4 is in the back right here. That's good. 1, 2, 3. This is R. So we can say that this is R. Let's do this one. Our H is in the back this time, so that works out well. Let's go 1, 2, 3. This is R. So we have 2 R's, and even if we have that symmetry, we have 2 R's. They don't cancel, so this can't be meso. So this is not meso. And then just to look at the last one really quick to see what's going on there. I don't know why it won't let me shrink these sometimes. Okay, there we go. Okay, this one we can say we've got our front carbon in blue, chlorine, methyl, and chlorine, and then H, H, and methyl. Well, we should notice that at first glance, we should kind of see, since we just connected these 3 together, we've got a chlorine and a chlorine, and we've got hydrogen and hydrogen. So this can't be chiral at all because it doesn't even have chiral centers, because you can't have 2 of the same thing attached to the same carbon. So this would be, this would have no chiral centers. There you go. That's how you do those. For this one, they tell us that we have a 2S and a 4R, and they tell us that it's a hexane and it's dibromo. So let's draw the hexane first. 1, 2, 3, 4, 5, 6. And then let's give it our 2 and 4 bromos. So 1, 2, and I'm just going to guess that the bromo is coming towards us, and the 4th one as well. And then we need to assign priorities. So again, you can split these up, or you can do it just based on what we know. So we know that there's a hydrogen coming off the back here on both of these. And we know that bromine's going to be 1, hydrogen's going to be 4, our methyl group will be 3, leaving us with 2 here. And hydrogen is in the back, so that's good. We can go 1, 2, 3. This is R. So we've got R. This one, we've got 1, 4, and then we have 2 carbons here. So we've got CH2, CH2. So we need to move to the next carbon. So we've got a carbon here and a carbon here. This one's C bonded to 3 H's. And this carbon is C bonded to bromine, bonded to hydrogen, and then bonded to another carbon. So this one takes priority. So we'll give this one 2. And this would be 3. And then we can go 1, 2, 3. Hydrogen's in the back, so that works. This would be S. And since that's exactly the opposite of what they asked us to do, or what they asked us to show, we know that we need to make a swap. So, because we had bromine in the front here, I can, with confidence, say that bromine will be in the back. And on this one as well, because when we have our hydrogen in the front, we have to switch the sign, the way the sign goes. And if you wanted to, you could check this pretty easily by saying hydrogen in the front. We can check this by saying 1, 4, we know this is 2, and this is 3, so we have hydrogens in the front, 1, 2, 3, this looks like R, but is actually S. Over here we've got 1, 4, we know this is 2 because we checked it earlier, and that's 3, we have 1, 2, 3, this looks like S, but hydrogen's in the front, so we have R. And that's what they asked us for. They asked us for 2S and 4R. And that's what we got. So I would just go ahead and redraw this. 1, 2, 3, 4, 5. Or 1, 2, 3, 4, 5, 6. And then put my bromines on dashes. And it's not necessary to show the hydrogens, so you don't have to. And then this would be what you would get as your answer.